Good morning to one and all. I'm Radha Silabina. I'm going to present the pattern feature extraction for image processing and computer vision. It is a comparative approach. It's just like a survey of paper. What are the feature extractions which are related to digital image processing as well as a computer vision? So coming to the 1 minute, I am sharing my PPT. My paper title is Future Abstraction for Image Processing and Computer Vision. It is a comparative approach. It is under the guidance of esteemed guidance of Dr. Rajesh Karma sir. I am going to present this paper. So abstract and the main titles are abstract, introduction, literature review, methodologies and conclusion. Coming to abstraction part, here we are discussing with various what is the digital imaging processing and what are the computer vision part and different feature extraction techniques which are available for digital image processing as well as the computer vision. Digital image processing is a technique for processing image digitally, and most of the part this any image will be presented on pixels. A pixel value will determine the type of image, whether it is grayscale image or RGB image. Coming to computer vision, it is a part of deep learning in which processing is done on the images. The main goal of this focus is on different feature extraction techniques applied by the computer vision as well as the digital imaging processing. We have various applications like robotics, object detection, weather forecasting, various domain of applications are available, both the digital image processing and the computer vision. So coming to computer vision, it is a part of coming to computer vision, it is a part of deep learning in which processing is done on the images. The main goal of this paper is focused on various feature extraction techniques. Coming to introduction part, feature extraction is a process by which certain features of interested image within the image we are detecting and representing for the further processing. Anyway, both the digital image processing and computer vision is the mainly focused on the visuals of the images. So future extraction will be the very crucial part or critical part in the computer vision as well as the digital imaging solutions. So later on it will be transformed, the digital image will be transformed into pictorial to non-pictorial so that we can represent for the data. So the resulting representation can be subsequently used as an input to the number of pattern recognition as well as a classification technique which will be labeled, or later on it will be classified. Later on it will be classified or recognize the semantic contents of the image. So future extraction is better to describe their features and attributes related to the image. So coming to literature part, methodology literature part, here we are discussing computer vision as well as the digital image processing. Computer vision will be, it is a mainly focusing on processing on the image. So here we are representing main focus of feature image analysis will be based on the image analysis and reduction of the noise. For example, reduction of the noise, distinction between and image darkening, edges and controversies. So like human imaging system, digital processing will image also require the digital pictures. It will be digitally processed and store them for the process. So digital image process focuses on large sort of the application areas within the domains of the life sciences, remote sensing, traffic observation, document analysis and retrieval, etc. So coming to the methodologies, so computer vision is generally it is a part of the artificial intelligence, and the main motive of this system is to emulate human vision by learning from the setting and having the ability to form the interfaces on the specific things and take necessary actions on the premises of the interfaces. So here we are following the parallel architecture for image processing so that we can overlap gap between the image process and image analysis. So it will recognize individual region or object inside the picture. So to create a particular sense of the content, we are using object analysis within the domain so that we can make a vision. Computer vision will extend the complexity of the particular image, and so that it will make a sense to particular image. So here various steps which are involved in image processing. Algorithms, different algorithms we have. First initially image will be taken, that image will be pre-processed, and later on it will be segmented as per the feature extraction techniques and algorithms. Later on this image will be converted into pixel value to non-pixel value, so that we can represent with the data images. So these are the various steps which are involved in the image processing. So coming to our paper, we are mainly focusing on the what are the feature extraction techniques which are going to be used along with the digital image processing as well as the computer vision part. So generally, day-to-day number of feature extraction algorithms are increasing as per the computer vision, as per the digital image processing. So here we are telling the different feature extraction techniques which are applicable for the computer vision and digital image processing. So nowadays, feature extraction is a very important crucial task for the implementation of any algorithm which is based on the images. So many features are in digital image processing. We have a sharpening or brightening or stretching of the image. Whereas in a computer vision, these images will be recognizing the object as well as your 3D images or 2D images which are possible with the computer vision algorithms. So these computer vision algorithms are, we have a shift, glow, sharp, PCS, different feature extraction algorithms are used along with the along with the computer vision. So here digital imaging, we are making use of different feature extraction. Based on that, we are going to set a model. That model will be given to the image, and that image will be processed digitally. Then only we will get a features or attributes which are related to that particular reason. So here most of the various applications of that particular computer vision are biometric recognition, fingerprint recognition, palm recognition, tissue layer recognition, military applications. We can have a human motion tracking, pedestrian behavior and analysis. So as per our focus on as focus on this paper, image processing will be mainly focusing on the processing the raw input image to enhance them or preparing them to do other tasks, whereas the computer vision is focused on extracting information from the input images or videos which have proper understanding to predict the visual input like human brain. Coming to image processing and applications, we are correcting illumination, changing the tones and sharpening. Whereas the computer vision applications are object detection, face detection, handwriting recognition, etc. So generally this image processing will be the subset of computer vision, whereas the computer vision is the superset of the image processing. This is the computer vision and image processing. So computer vision will act like a human brain, how it is processing, how it is storing, whereas the image processing will be how we are visualizing the thing, how you are digitally processing the image. So that is the difference between computer vision and the image processing. Anyway, both will be based on the visuals or the images, but how the techniques will be implemented and deployed for using of the data representation is different. So mainly focusing on the feature extraction techniques. So these are the feature extraction techniques like edge detection, color features, shift algorithm, GLSM algorithm, PC algorithm, shape features algorithm, text features algorithm. These are the different feature extraction techniques we are going to use with the both the computer vision and the digital imaging processing. This is a sample vision. This will be extracting. This is a small normal bike which will be depends upon whatever the algorithm we are using, like shift algorithm, scale, that is a scale invariant feature transform algorithm, or sharp algorithm, speed up robust feature algorithm. Based on that, we will display each and every small part of the image. So we are referencing these are the papers, and coming to these computer vision, these are the different algorithms we are using with the computer extraction techniques. So mainly we are focusing on the what are the future extraction techniques, how it will be useful for the computer vision as well as the digital image processing. Thank you.